Hello everyone, my name is Tyler Watson and today I'll be presenting to you my Lab 5 report. Experiment, I've chosen to investigate the trajectory of a golf ball being hit and tracking it as it travels through the air and until it reaches the ground. I chose this topic because it piques my curiosity and allows me to dive deeper into the activity of projectile motion and apply it to a real-world scenario that I'm very familiar with. By modeling this motion of the golf ball, I'm able to gain a better understanding of how these different factors impact the initial velocity as well as the launch angle and influence of its trajectory of the golf ball. To complete this experiment, I filmed myself hitting a golf ball on my smartphone using an application called Tracker. Tracker was able to analyze and collect data from this video and track the golf ball as it was flying through the air, collecting data, everything such as trajectory, position and time, as well as speed and launch angle. Using this data collected, I was able to put together information into GlobeScript and calculate a theoretical trajectory of the golf ball as it was flying through the air. Using this data from GlobeScript, I was able to create a model that was able to track the position of the golf ball as it was flying through the air using different principles of projectile motion. I considered the golf ball as my projectile as it flew through the air, only under the influence of gravity with little to no significant air resistance, just to simplify the experiment as a whole. I used different equations that were derived from these principles to predict the motion of the golf ball, and using my GlobeScript coding, I was able to create a model that was able to analyze different factors of the golf ball. So this was my actual experiment, as you can see on the screen, hitting the golf ball using the Tracker application to track the position as well as the time of the golf ball as it was flying through the air. Using this video, using the Tracker analysis, and as well as my GlobeScript code, I was able to collect these different data measurements and put them into a table. As you can see here, the launch angle of the golf ball was 16.4 degrees, and its exit velocity was 123.7 miles per hour, creating an overall air time of 4.8 seconds. Its maximum height that it reached was 54 feet. And when it was at 54 feet, it was 103 yards away from its initial starting position, and then all the way from when it was hit until it reached the ground at the end was a total of 167 yards. In conclusion, I was able to apply the principles of projectile motion and calculate the theoretical trajectory of a golf ball with little to no air resistance under the influence of gravity. And by combining the real data from the Tracker application to my GlobeScript computational model, I was able to gain different insights on different factors that would impact the ball's initial velocity and launch angle and other effects that happen in the real world. This investigation demonstrates the applicability of physics and how we can relate real-world applications to theoretical models and help us gain a better understanding of different complex physical systems. Thank you, and let me know if you have any questions.